So probability is the likelihood of something happening. What does Lloyd, from the video that we watched, that's right here on this picture, what does he not understand? That 1 out of a million is not a very good chance. But what does he understand? There is a chance. So yes. So you're telling me there's a chance. Yes, I'm telling you there's a chance. However, I'm telling you that this is probably not going to happen. The probability of that is very, very low. All right. So let's jump back to this. You can go ahead and look at your slide. This slide number 9, your slide number 9. If you're doing multiplication tables, what would go in this box? 2, because right. So you see 1 and 2. You're going to multiply those, and you're going to get 2. What would go in this box? No, 6. 3. I'm sorry. Well, the one that the cursor is 3 and 2 is going to be 6. What about 1 and 5? 5. And what about 3 and 5? 15. Now you guys understand that is not super foreign to you. You get that. What happened when we're doing Punnet squares? The dad generally goes on the top. The mom generally goes on the left. If you mix those up, it's not a big deal. Just try to do it that way. So let's go ahead and practice this one. 3, number 3. What goes in the top left box? Don't use the word A, the letter A. I want you to tell me using the words we practice. Homozygous dominant. Yep. What goes in the top right box? Heterozygous. Yes. Big A, little a. All right, this one, bottom left. Homozygous dominant. And the bottom right box goes heterozygous. All right, in a nice world, that would all be in the middle. There we go. All right, I want you to go ahead and try to do number 4 on your own. Go ahead and try to do number 4 on your own. And if you'll see over there to the side, big A equals brown hair, and little a equals blonde hair. You can use whatever letters you want. That's what we're using right now. So go ahead and fill out number 4 on your own right now. So let's look at number 5. Number 5. Number 5. Let's say that I gave you this. If I gave you the percentages, could you work it backwards? Could you figure out what the parents are based off of this? So go ahead and try to do number 5 that way. If this was it, if you want to go to mine and copy mine, or if you just want to type them in, that's fine. So do number 5 and then do number 6. I'm going to do both of those, number 5 and then number 6. All right, so you've had a variety of practice. Let's go back to number 4. The answers for this should be homozygous dominant, heterozygous. So if you'll notice, essentially, these were the answers for this. But you should be able to do it backwards or forwards. If given the parents, you should be able to get the offspring. If given the probability of offspring, you should be able to get the parents. How would you fill out these boxes at the bottom? Off of number 4. So based on number 4, we're looking at specifically number 4. How would you base, what would you write here? So what is the percentage of getting a homozygous dominant? What is the percentage? 25%. What are the chances of getting heterozygous? 25 and 25, which is 50%. Because you see there's one right here, and there's one right there. There's 2. What are the chances of getting homozygous recessive? 25. Now, if you've done your math right, and you know how to count quarters, you know that should equal $1. That should equal 1 or 100%. All right. Now, here's the application question. If capital A equals brown hair and lowercase a equals blonde hair, what is the percentage of brown hair, the probability of having a brown-haired child? What are the percentages? Brown. There's 1. That would give you a brown-haired child. That would give you a brown-haired child. And that would give you a brown-haired child. That's going to be 75. So either doing math or just counting right here, that's going to be what? It's going to be 25. All right, so the chances of brown is what out of what? Chances of brown, nope, branch of brown is 3 out of 4 for how many percent? 100. Or 1 out of 4 for 25%. Do y'all understand what to do? Y'all understand it? Does that make sense? All right, go ahead and pass out the on the ends of your desk or the SpongeBob SquarePants stuff. This assignment starts out super simple, and then gets more and more complicated as you go on until by the end you're able to do this whole thing all by yourself. We'll go over this a little bit at a time. All right. For number 1, it says for each of the genotypes below, indicate whether it's heterozygous or homozygous. I think you can do that pretty easily, so we're not going to spend much time on that. So big capital T is going to be what? H-E or H-O? H-O, because it's homozygous. So you're going to write he-ho, 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 whatever, H-E or H-O. Just read the directions on that. I think you got that one. And then for A and B on number 1, you're just going to list all the ones that are H-E, purebred, hybrid, homozygous, and all the ones that are hybrid. All right, let's go down to number 2. Stop doing number 1. Stop doing number 1. Look at number 2. Determine the phenotype for each genotype using information about SpongeBob. So it says yellow body color is dominant. So what do you know about a capital Y? What is that going to give you? Dominant. What is a lowercase y? What is that coded for? That's going to be the recessive. And what color is that, though?
Yellow.
Blue. No, the lowercase is blue. So what is a capital Y going to give you? What phenotype will it give you? It's a yellow body color. It says, remember, and the directions right there says yellow body color is dominant to blue. So out to the side, maybe you want to write yellow equals big Y. And then for the square, what could you write? Square equals what?
Dominant.
Big S. I would write. I mean, you could write dominant, yeah, but it says it in the directions. I would be writing notes out to the side. Number 3, for each phenotype, give the genotypes possible. So this is the opposite of number 3. Number 3, they give you the genotype, you write the phenotype. Now they're giving you the phenotype, what they look like, and you're going to say, well, these are what is possible. And there's a little hint there. Ms. Sims gave you a little hint. It says a tall head, capital T, is dominant to a short head, little t. So if somebody is tall, what are the only 2 possibilities for their genotypes? Yeah, big, everything on here is going to be T's. So tell me TT doesn't help. So it's going to be, go ahead and write down on that slide, on that line. For tall, put big T, big T. Y'all see why that would give you a dominant trait? And then what are you going to write beside it? What's the other one? No, big T, little t. To show the dominant trait has to be there, right? Okay, so what's going to go over there on short? No, if there's a big T there, it's going to be tall. It's going to be little t, little t. Little t, little t. If you want to reference this slide over here, y'all remember the slide that I showed you? Look right here. Big A is going to show the dominant trait. Big A, little a is going to show the dominant trait. Little a will show the recessive trait. So if you don't know these vocab words, this becomes really, really, really difficult. If you know these vocab words, this is just a small puzzle, like a, I don't know, like a Sudoku puzzle or a crossword puzzle or something like that.